What's coming in Vue 3.0? First, we're going to make it faster. Well, Vue is already pretty fast, but it could be faster, so why not? And make it smaller. It's already pretty small, but it could be smaller. Make it more maintainable. This is for our quality of life. So we have hundreds of issues, and we probably get like 20, 30 issues every single day. So for us, just making sure everything is more maintainable, well decoupled, and easier for external contributor to read the code and understand and contribute is also extremely important for us. Make it easier to target native. We currently do have some solutions that allows you to use Vue to render to native targets, but some of those implementations are a bit hackish because it has to fork the Vue source code. Although we do have the internal infrastructure for doing that, it's not exposed as a standardized API. So we want to change that. And make your life easier. So these are a bunch of quality of life improvements, new APIs that will just make it easier for you to write your application. All right, so let's dive into the details. The first, we want to make it fast, make it faster. Virtual DOM implementation. So Vue uses Virtual DOM, and Virtual DOM has an overhead. And our previous implementation over time has grown. We had a lot of edge cases. So we did a ground-up rewrite, and in that process, we learned a lot of micro-optimization tricks from other competing solutions. And the result is we have a new Virtual DOM implementation that's almost double the speed in common mounting and patching scenarios. And we also have more compile time hints to reduce the runtime overhead. So Vue currently already does that to some extent. So in case you don't know, when you write your template and give it to Vue, Vue actually uses a compiler to compile your templates into something called JavaScript render functions. These are functions that return virtual DOM, and the code that it generates can be optimized by the compiler. So the compiler can statically analyze your template to extract information about what you intend to do, and then generate code that will be as efficient as possible at runtime. And because this compiler work is done at build time, so all of this work, all the work reduced at runtime benefits your users, so you're not incurring any additional cost for your actual runtime performance. So I'm going to dig into the details of a few possible optimizations. So if you've used React or you're familiar with a virtual DOM implementation based framework, you probably know that virtual DOM does incur a bunch of overhead. And a lot of times when React developers try to optimize their applications, it's really about just kind of working, battling against the virtual DOM, trying to reduce its work done as much as possible. So with a compiler, there's a lot of work we can do for you without you having to do anything. So the first thing we are going to introduce is we're going to generate more efficient code that creates these virtual nodes. So this looks super verbose, but the reason it is doing so is because we want to ensure that every single call to these create fragment, component vnode, element vnode calls, they receive consistent number and shape of arguments. So this is called monomorphic calls. And JavaScript engines love that. So if they see a function and the function keeps getting called with the same shapes of arguments, then the compiler is like, hey, I can optimize that. And VA will do its work and make your code super fast. So we want to generate as much monomorphic code as possible. And then there is component fastpath, which means just by looking at your template, if something is uppercase, it's most definitely a component, right? So we can just directly generate code that creates a component instead of having to, at runtime, check, oh, if this tag is a component, I'll generate a component, otherwise I'll generate an element, right? So we skip a lot of these guesswork at runtime, and we can do that by inferring the information at compile time. And then there's children type detection. Basically, we're telling the compiler, telling the runtime, hey, this div only has one single children. So you don't even have to assume it's an array. You don't even have to check if it's an array. You don't have to do the iteration and try to diff the children. You just compare this single child, and that's it. So it skips a lot of unnecessary work for the runtime, which just makes it, and when all these little things add up, your whole application just becomes substantially faster. Optimized slot generation. So many of you have probably used slots. One of the problems with slots in performance is when a component has slots, it actually has to always re-render when the parent re-renders. So when the parent component re-renders, the child component with the slots always have to re-render to ensure that the content passed to it by the parent is up to date, because it doesn't really know whether the parent content has changed or not. So in the 3.0 code, we'll generate these slots as a function that's being passed down, kind of like scope slots. And the benefit of that is because Vue components keeps track of their own dependencies, right? Previously, slot content is rendered in the parent scope, and thus the dependencies are tracked in the parent scope. So this hello here is actually tracked in this parent scope, instead inside the comp itself. By turning it into a function, we are deferring the rendering of this part later into the child component itself. So when the child component renders, that's when it actually calls this function. This makes this .hello collected as dependency of the child instead of the parent. So now parent and child are cleanly separated, have their own complete set of dependencies, and if hello changes, only the child re-renders. And if something else changes, only the parent re-renders. So this results in a much more precise component update cycle. When you mutate state in your Vuex store global state, you can be more sure that there will only be the components that's affected being re-rendered. And this is something you don't even need to think about. Whereas in React, you'd have to do a lot of pure component, should component update. And I think this is one of the most important distinction in terms when you have a big component tree. Vue ensures that you get an optimized component update cycle. Static tree hoisting. So this is something Vue 2 is already doing. And to think about it, right, the overhead of virtual DOM comes from you have to always re-render the world. So this part, this span on the left, it actually never changes. But in a naive virtual DOM implementation, you're always recreating virtual nodes for this part and then trying to diff them. And our compiler, it can easily detect parts that are actually completely static and then hoist them out of the render function entirely. So this is just a constant tree, and we reuse the same tree on each re-render. And the diff algorithm, so first we avoid the cost of repeatedly creating these objects and discarding them, the memory garbage collection cost, and then in the diffing process, because this is a constant, we see it's the same on each pass, and we just skip the whole tree. So we're not doing any unnecessary work. And then, if an element has dynamic content inside of it, this means we cannot just hoist the whole tree. However, we can still look at its attributes and see whether it has static attributes. So we notice that this element, all its attributes are static, only its contents are dynamic. So we can hoist out the properties that we are passing to this virtual node, again, into a constant. And next time when we diff this same node, we notice that its attributes is the same object, so no work needed. We just skip it and directly go to its children. So with these two combined, we can almost eliminate most of the overhead in terms of diffing on changing content. So essentially, our virtual DOM diffing algorithm is really just focused on the parts that are dynamic instead of the parts that are static. And then there are inline handler hoisting. So these are kind of like micro optimizations, because when you pass an inline function, this code generates an inline function by default, and the inline function gets a new identity on each render. So when you pass it down as a prop, it actually causes the child to always re-render. So we can automatically hoist this one and cache it so that as long as it doesn't depend on any iteration scope variables, This one is cacheable, so on each render, the child component receives exactly the same function, so it knows it never needs to re-render. Okay, so that was the compiler. So with all of those things add up, it can invisibly improve your performance without you even being aware of it. Now, proxy-based observation mechanism. So Vue2 uses a getter-setter-based observation system. So when you mutate state in your Vue application, you're in fact triggering getters and setters that's being installed into your data objects. So we do that by using object-defined property, which is ES5 API. And that was the primary reason that Vue did not support IE8. Now, ES 2015 is now becoming more universally available in evergreen browsers especially. So we want to take advantage of that, and we explore the opportunity of using ES 2015 proxies to re-implement our observation mechanism. And the result is actually fantastic. We get full language coverage, which means we're getting rid of a bunch of caveats in the current Vue change detection system. So adding new properties, deleting properties, setting an array index, mutating array's length, and even support with map set, weak set. These are all possible using proxies and are already implemented. You can even use a class to be an observable. And also, it results in much better performance because you don't have to, proxy-based observation is actually lazy by default. You don't have to recursively convert every object to make it reactive. We can convert them only on demand when they're accessed. So instance property proxy also gets a performance boost using native proxies. Right now, we know that on a Vue component instance, we're proxying pretty much everything. We have your computed properties, your data properties, your props, methods, everything is on your component instance, right? And a lot of these are in fact defined as getters. And when we define a getter using defined property, we notice that this is actually a relatively expensive operation. So, and this turns out to be one of the biggest overhead when creating component instances. So if you compare, say, 3,000 component instances versus 3,000 normal elements, you find the components are much slower to create because of all of these overhead. And in 3.0, we're giving each component instance a proxy of its own, and the proxy just dynamically decides what thing, it will check the component's definition and return you the property, the proper values when you are querying a property, whether it be a prop or computed or data. And that, in fact, also reduces a lot of work when you create instances and just has even better runtime performance as well. So we are doubling the speed of component instance initialization as well. And pretty much we are across the board with all the prior optimizations mentioned combined, we're getting double the speed across the board and half the memory usage of Vue's current runtime. And all of this doesn't really need any breaking change in terms of our usage API. So this is screenshots of two benchmarks. These are really simple benchmarks, but just kind of to illustrate the point. We're rendering 3,000 simple components. They are stateful component instances. Each of them has its own observable data object, have its own props, and everything. Previously in 2.5, we are looking at like 280 milliseconds, fluctuating a bit over around that, and 22 to 48 megabytes. And you can see we are using less than half the memory and less than half the time. So this is time spent in JavaScript in your app. And just doing in general, in other cases, we're seeing similar improvements too. So this is just making it faster. Okay, so make it smaller. Vue currently has a runtime of around 20 KB gzipped. And a lot of that is actually due to the fact that we are bundling everything together, shipping as a monolithic runtime. And some of these things you probably are not using. For example, the transition component, sometimes if you're shipping an app that's just doesn't need to be fancy. You probably are not using any transitions. Sometimes you may be using a custom form component and not really using the DOM native V model. And any directive you use, actually, a lot of them have a corresponding runtime helper. And some of the components like keep alive or async components, they actually also have some associated code for them. So a lot of these can actually be made tree shakeable. So in Vue 3, we are pretty much redesigning our code structure so that anything that's not absolutely necessary to just render a hello world component should be tree shakeable. So this means built-in components like keep alive, transition, template director, runtime helpers, utility functions like creating async component, creating mixins, memoizing static trees. All of these helpers will become functions that can be imported via the ES module syntax. And if you don't import them, a lot of them can be tree shaken. This also means in the compiler, we are generating tree shaking friendly code. If you use a feature that requires a certain function in your template, the compiler will automatically generate code that imports it. But if you don't use a feature, then we generate code that does not import it, which means the feature will be tree shaken when you build your app. So this also happens without you having to memorize anything. Just import things if you need them, leave them out if you don't, and all the things that's not used gets tree shaken. So with all the unnecessary stuff tree shaken, and Hello World app will be around 10 KB gzipped in the new runtime. So again, we're slashing off half the size. Okay, so make it more maintainable. We want to make sure that we can keep Vue going for as long as possible. We want to make sure that we stay with there with products that have a long-term vision. So first of the things we did was 3.0, we actually migrated from Flow to TypeScript. This is mostly because we're noticing that the Flow team versus TypeScript team is really like reaching out to us, working with us, and has a much better engagement with the community. And in terms of user consumption, TypeScript is also much more popular. And most importantly, our current TypeScript definition for 2.x is sort of an afterthought. It's bolted on top and is completely separated from our actual code base. So this creates a lot of maintenance overhead. And in 3.0, the code base is actually rewritten in TypeScript. And this actually means that we naturally get type definitions generated whenever we build the library. So it will feature much better TypeScript support in 3.0. But rest assured, if you don't like TypeScript, you don't have to use it. All the APIs are carefully designed so that they work pretty much the same in vanilla JavaScript as well. Decoupled packages. So 3.0 code base is migrating to a monorepo format, which means we are splitting our internals into more clearly defined packages. Well decoupled, each of them have its own API contract, each have its own test suite. So compiler core observer, so the observer mechanism, the observer implementation becomes standalone. And in fact, you can import it individually and use it without the rest of Vue if you want to. The runtime is also designed to be more modular. So runtime core contains everything that's platform agnostic. So it does not assume the presence of Node API or web browser API. It's just pure JavaScript. Now, a runtime DOM builds on top of runtime core to make everything work in the browser. And runtime test runs on Node.js, so you can render your component even without JS DOM, and you can even log all the Node DOM operation it's performing and then dump them to inspect if something is wrong. And then the scheduler is the part that's responsible for scheduling updates and has some interesting possibilities in there, which I'll show you later. Server renderer, the name says what's it about, and you don't have to really know about these internal packages if you don't want to. The final Vue package is assembled using all of these internal packages. And this is mostly just for us internal maintenance. And for you, the end API exposed will still be this single nice-to-use Vue API that you already know. And we have two builds. The compatibility build is the one that maintains as much the same behavior with the current 2.x as possible, and we'll talk a bit about that later. So the compiler is also being rewritten. So we want to rewrite the compiler to be more modular. We use a pluggable architecture so that, for example, a single optimization can be a plugin, a directive can be a plugin, and so that it makes easier for people to contribute. Parser with location info. This means we're aiming to give you source maps. When you have runtime render errors, it'll point to the template source instead of cryptic render function code. We also want it to serve as an infrastructure for more robust IDE support. So currently, ESLint, plugin Vue, and Vector all kind of implements their own parsers. Prettier uses it, custom Vue parser. And we want to unify all of these, and we want the new parser to be able to serve as the common infrastructure so we don't have all these duplicated effort in the community. And, okay, make it easier to target native. So this is the custom render API that we're going to ship in the new runtime. So when you import the create render function, and you just give the minimum arguments node ops and patch data. So node ops are just a bunch of functions like append child, insert before, remove child, typical DOM operations that you can think of. They are pretty much just bridges to the actual DOM API calls. So the nice part of this is, say, the developer of native script Vue, if they are using Vue 3 to power native script Vue, they can just use this API and bridge all of this to the API calls to their native renderer. So this will easily enable them to use the Vue runtime as a dependency and render to native targets like iOS and Android. This will, it also becomes trivially easy for them to upgrade Vue instead of having to always update their fork. Okay, so make your life easier. The first thing we're probably going to do is we want to expose the reactivity API because the concept is actually a bit of hidden in current Vue 2.x. We want to give you the ability to explicitly create objects that are reactive. So if you import observable from Vue and create a state object, this object is reactive now. So the effect function means you want to produce some side effects, for example, logging to the console, that relies on some piece of reactive state. So this side effect, a console.log that relies on state.count, once it's being executed, it tracks its dependencies now. So whenever you mutate the state, this line gets called again. So internally, every Vue component uses the same API to track the dependencies during its render and to determine when to re-render. Okay, so this will actually also make it trivially easy to say just create an observable and share it between your components. That's like the minimal viable state cross-component state management that you can use, and it's extremely simple. You can even pass in a class here, a ES 2015 native class, and methods inside the class will also work. So you can kind of just use a class as your model, pass it around, and share state between your components. Easily identify why a component is re-rendering. So this one is actually pretty important because a lot of arguments against a mutable state management pattern like Vue is that, oh, it's hard to understand what's going on when you mutate stuff. Everything just triggers. So now we're giving you the ability to just pause the world. You put a debugger inside the render triggered hook, and you can, in your dev tools, you'll be able to just look at the world as it is when the component is triggered, and you get an event. So I kind of want to do a quick demo of what this really means. So this is the reactivity tracking. Open the console. Oops. Is it doing anything? Debugger. Oh, there should be a button somewhere, but it's not doing anything. Well, this is weird. Oh, right. I need to serve it over HTTP because I'm using modules. Just 1 second. Whoops. This is Vue3 demos. So, reactivity tracking. And so we have a counter here, and if we press the counter plus, you notice that we get an event here, and the event actually gives you precise information on what is going on. So we see the target. The target is count2. So this is the object that's being mutated. We see the runner. So the runner is actually the reactive side effect that's running for a certain component. And then we see that the key count is being mutated, and the old value is 1, and it's being mutated to 2. So you know exactly what's going on. This is kind of like a mutation payload in Vuex, but you get it for free. You don't have to do anything special to get this. And more importantly, inside the stack trace, when you pause inside the render triggered, and you're seeing all these here. You can actually use the Chrome DevTools, going to settings, going to black boxing, and enable black boxing Vue.js. And voila, this is your stack trace. You see, you directly go to the line. You can directly go to the line that is causing your state to be changing. So now, you don't need to do any guessing. So it shows exactly where this component was triggered to be re-rendered. So this helps you understand what's going on in your app. And it's super simple to use. All right. Okay, so improved TypeScript support. So we mentioned this before. And a lot of you, if you use TypeScript, you probably prefer to write your components using something like a Vue class component or with decorators. So in Vue 3, we support class components as a first class API. So if you use TypeScript, you most likely just want to use the native component API. So class hello extends component, you import this from Vue. You can define an interface for your props. You can define an interface for your data if you want to, but you don't have to. You can really just use the fields to define reactive data on your component. And you can even use TSX. So if you know what TSX is, it's kind of, if you use React, you know what TSX is. But the benefit of using TSX is you actually get full type inference here. So you can see that this component, because it defines count as 0, this dot count will be inferred to be number here. So if you do like this dot count plus a string, well, it allows you to do that, unfortunately. This props text is text, right? So, and more importantly, because this hello is defined as a component which has its props definition, and then when you use it elsewhere in a parent component and you say text hello world, if I change it to a number, I actually get an error saying number is not assignable to type string because this component expects text to be a string. And if I just don't do anything, it also gives me an error saying text is required because it's not an optional property. So if I make it optional, the error goes away. So full TSX support, if you're into that, which is really helpful if you are big on type inference. And then we have better warning traces. So previously our warning traces, we do give you a nice component trace showing the hierarchy of the component that's currently triggering the warning, but it did not include functional components before, and we're doing that in 3. And inspectable props, so in the component trace you actually get interactive props that you can like crack open and see which each component is receiving. And trace is also available in more warning cases. In a lot of places previously, you get a warning but you don't get the warning trace because we had to pass the component instance all the way into those places in order to make the traces show up. But we've re-architectured the warning implementation so that it's easier to just throw in a warning and it'll always automatically infer where the current component is being rendered, and it'll give you the nice component trace to help you identify the problem. Okay, so experimental hooks API. How many of you have heard about React hooks? Okay, a lot of you. So I don't think I have enough time to just dig into hooks, how hooks work, but hooks is a pretty, I would say, important and exciting composition mechanism that's being proposed by the React team. And it's not specifically bound to React because the concept actually applies to almost any Vue layer framework. It's just a generic way of reusing logic and composing them. So on a high level, just think of, so right now when we write Vue components, we define our Vue component as an object with options, right? We have data, computed, methods, and all the other options. And it's an object, and the way we reuse these options is most of the time we create a mixing, or we use some other form of component reuse like scope slots, which Adam will probably talk about later today. But the idea about hooks is that it allows you to define a component's data, methods, computed using pure function calls. And these function calls becomes freely composable, so you can group a data call, a method call, a computed call into another custom function, and then pass them around, use it in different components. This makes them much more composable, very reusable, and at the same time, it achieves what mixing does, but at the same time avoids some of the gotchas of mixings. For example, when you use a mixing, multiple mixings, you don't really know which property was provided by which mixing. But with hooks, all the provided values are returned by the hook as a return value of the function call. So that makes it super explicit. I think I'll skip the demo, but on GitHub we do have a project called Vue-hooks. It already implements the same React hooks API experimentally, and it already works with Vue 2. It's actually very simple to do, and we also have something working similar for Vue 3. But the general idea is hooks is an interesting idea. It's technically very easy to implement, and we are thinking about how to better integrate it with Vue. We might, will likely not just directly use the exact same API, but we'll think about how to integrate hooks in a way that would fit better with idiomatic Vue code and benefit users. So most likely it'll be a replacement for mixins. Okay, experimental time slicing support. So React team also announced something interesting called concurrent React, which one of the features is called time slicing. So, and it addresses a pain point of modern JavaScript framework is that they spend so much time in JavaScript, right? Although Vue is pretty fast, there are some cases that can make it slow. So if I go to the time slicing example and go to the time slicing demo here. So let's look at the code. So here I have a block function. What this block function is doing is it uses a while loop to just block the main thread for 1 millisecond. So it does nothing until 1 millisecond has passed. And we are simulating a very expensive component which just blocks for 1 millisecond in its render function. So if we were to render 200 of these components, so I'm using render functions here, but you get the idea. So we're rendering 200 of these at the same time. It'll take 200 milliseconds at least, right? And each update, they are actually sharing some common reactive state that we created with the observable API. And whenever we mutate share.message, all 200 instances will have to update. And that, again, is a guaranteed minimum 200 milliseconds work. So let's take a look at what Vue today by default does. So typing here will update 200 component instances at the same time. So I'll do like, right? So it's kind of okay, but what if I'm typing fast? it's like freezing, right? It's not responsive at all, especially like when after I'm typing, because it's doing all the work, you can't even scroll the page, you can't even click on anything else. The browser becomes completely unresponsive. But what time slicing does is, if we take on the performance tab and start recording, and we stop recording, you'll see that I'm typing as usual and the browser is responsive. It's doing a lot of work, but the interesting part is, oh, this is so hard to drag around. Okay, look at these flame charts. So it's not a single big block of JavaScript execution. Instead, every piece of work is divided into 16 to 17 milliseconds. So we're doing work for 16 milliseconds, and we yield back to the browser to allow user inputs to come in, and then we keep doing work. And during that process, we also have a lot of interesting things going on, because we notice that if we type 1 and then immediately type 2, and if we type 2 before the 1 update finishes, the 1 update is actually invalidated. It's useless. So maybe we're only halfway through the 1 update, and the 2 update comes in, so we can throw away all the work we previously did for 1 and discard the work that we haven't done yet. So this is the key here, because we are discarding work that we did not have to do and did not have time to finish. So, so this gives us a completely responsive input box while the browser is still doing its work as much as possible. So, and you need to use any special API to get this behavior. It's just like when we turn it on, it just works like that. So this is pretty important in terms when you have a super heavy application and want to ensure your application stays responsive. So this is already, it's experimental, but it's already implemented and working in Vue 3. So, cool. So that's actually most of the things that I want to talk about Vue 3. I hope that gets you excited and looking forward to it. And I know the inevitable question that I will get from some of you is, hey, it uses proxies, so what about IE? ToolonDR is, IE11 will be supported. So we know that it won't die until 2021, which is a pity. I hope Microsoft just reconsider it. But in order to support it, we're actually going to ship a build which includes both the ES5 getter and setter based detection and the proxy based detection. And it will fall back to the getter setter based detection in IE11. But the downside is you will have to specify whether you want to support IE11 so that we can warn you when you use the API in a way that won't work. When you assume something that will work but it won't work in IE11, right? Because the limitation is, for example, in Vue 3's proxy-based build, you add a new property and the change will trigger. But in IE, it won't be able to detect that. So when you do that and you have the support IE flag on, we'll actually throw a warning for you telling you, hey, like you can't do this if you want to support IE11. So, which means you'll be able to support IE11 as long as you're willing to live with some of the existing caveats that Vue 2 has. But I mean, it's not going to be worse than today, right? So that's all. Thank you very much, and I hope you enjoy Vue 3 when it's released.